continuing along, let's see where we left off. We left off on part D. Is now we want to find the probability of drawing a 10 or a face card. So let's see. So just like before, we'd start out with the same formula, which is starting out with, let's find the probability of drawing a 10 first. Well, remember, there's only one 10 in each suit, and then there's 4 suits. So there's one 10 in each suit, and then times your 4 suits, which is a total of 4 10s in your total deck of 52 cards. Remember, just like before with the OR, remember the OR means that we're going to add things up. So with the OR, we're going to add. And then we need to add up any face cards. Was the second thing that they were asking about face cards? Well, there are a Jack, Queen, and King that are face cards. That's 3 face cards in each suit. Times the 4 suits is a total of 12 face cards in the entire deck. So that gives us out of a total of 52 cards. Now, again, we're adding because the question is, do we also need to subtract anything? Well, the only way we need to subtract something is if there is an overlap. And is there an overlap? Is there a card that is a 10 and a face card? Something that could get counted twice, and there isn't. So you can either look at this one of 2 ways. You can say, okay, I can subtract 0 because there's no overlap, or you can just leave it alone. There's no overlap to subtract. So we can just go ahead and add normally. So remember that they already have a common denominator, so that will stay the same. We'll just add straight across the top, which is the 4 plus the 12, which is a total of 16. So again, we get 16 out of 52, which is 0.308 again. That's our probability of drawing either a 10 or a face card. Here's another one. P, and then we've got 10 with a bar. That means what's the probability of not drawing a 10? Well, remember that there's a total of 52 cards. Remember that 4 of them are 10s out of the 52. That means the other 48 out of the 52 are not 10s. So what we have for not 10s is that there are 48 out of 52. And that gives us a total of a probability of, when I divide it out, of 0.923. Okay, and we're done. Let's try one last one. Find the probability of drawing either a red or a black card. And let's see how that goes. Well, let's see. Let's take a look at the red first. Well, there are 13 hearts and 13 diamonds for a total of 26 out of the 52 that are red. Remember, because of the OR, we're going to add. Now let's count up how many black cards we have. Well, remember that there are 13 clubs and there are 13 spades. So that's a total of 26 out of 52 black cards. Now, there's no overlap. You can't be a red and a black card at the same time, so I don't need to worry about things getting counted twice, so I don't need to worry about subtracting anything. I can just add normally straight across the top. I already have a common denominator, so that will stay the same. So the 26 plus 26 will get me 52. Out of 52, which equals the number 1, which remember is possible. What this means is you will definitely draw a card that is either red or black. Well, that makes sense because all cards are either red or black. So you're either going to draw a red one or a black one. Your chances of that happening are 1 or 100%. That definitely makes sense. Let's take a look at a few more examples. On this next one, we're rolling a single die, which means we're rolling a 6-sided die, which means we'll have the numbers 1, 2, 3, 4, 5, and 6. And on this first one, we're looking at the probability of rolling an even number. Well, what's considered to be even? Well, even is considered 2, 4, or 6. Well, there's 3 options that are even then. Out of how many options are there total? Well, there's a total of 6 numbers. 1, 2, 3, 4, 5, 6. So 6 options. So out of 6, which gives us, if you divide 3 divided by 6, you get 0.5. That's our probability. You got a 50-50 chance, in other words, of drawing an even or rolling an even die. Let's take a look at this next one. Find the probability of not rolling a 6. So that means 6 with a bar on it is that they're looking for. Well, what's considered not a 6? Well, not a 6 means 1, 2, 3, 4, or 5. That means you've got 5 options of rolling things that are not a 6 out of a total of 6 choices. So the chances of not rolling a 6 would be 5 out of 6, which is 0.833. That's your probability of not rolling a 6. Let's take a look at C. In C, we have the probability of rolling an even number or a multiple, I'm going to be careful, multiple of 4. So be careful with or. The first thing we'd start out with is the even. We already did that. Even is the numbers 2, 4, and 6. So that gives us 3 options out of a total of 6. Just like before in all these other problems, our or means that we're going to be adding. And what are we adding? We're looking at multiples of 4. Well, there's only one multiple of 4 on a die, and that's the number 4. So there's only one way to get a multiple of 4, and that's the number 4. Out of, again, a total of 6. Now, the problem with or is whether or not you need to subtract an overlap. Is there anything that got counted twice? Something that was both an even number and a multiple of 4? Well, there was. The number 4 got counted twice. So one number got counted twice, so we're going to subtract that one number that got counted twice. Again, keeping the denominator the same. 1 out of 6 of the numbers got counted twice. So then I've got a common denominator, go ahead and add and subtract normally straight across the top, which is 3 plus 1 is 4, minus 1 is back to 3. So I get 3 out of 6, which is 0.5 as my probability once again. It gives me 0.5 as my probability once again. And that's it. Let's try one last one. The last one is finding the probability of a multiple of 5 or a multiple of 3. So the OR rule says start out with the first one first. What are considered to be multiples of 5 that are on your die? Well, that's just the number 5. So there's only one out of the 6 numbers that are divisible by, or that are multiples of 5. Now again, remember the OR means that we're going to be adding. Question is what? Now we're going to look at what are the multiples of 3. Well, what's a multiple of 3 that's on a die? Well, there's 3 and there's 6. So there's 2 options that are multiples of 3. 3 and 6. So that's 2 options out of 6 numbers on a die. Now the question would be, is there any overlap? Are there any overlap between the two groups? Meaning, are there any multiples of 5 that are also divisible by 3? Well, there's 5 and 3 and 6. These don't overlap anywhere, so there's no overlap. I don't need to subtract anything. So that means I can go straight across the top, adding normally. The 1 plus 2 is 3, and leaving the bottom as 6, which gives me 0.5. And that's our final answer. Let's take a look at this next one. And this